Hello, welcome back to this channel. In today's tutorial, we are looking at how to solve systems of equations using Gaussian elimination. Of course, we have so many ways to solve such equations, but today we are looking at how to use Gaussian elimination strategy to solve system of equation of this nature. Now, the first thing to do here is to write the system of equation in a matrix form, and then we convert the matrix into a row echelon form. Now, what do we mean by a row echelon form? We say that a matrix is in a row echelon form if the first non-zero entries. So let's say we have a matrix of the form 1 3 negative 1 0 1 negative 1 0 0 1, and we are asked whether this matrix is in a row echelon form or not. Now, a matrix is in a row echelon form if the first non-zero entries of the rows are equal to 1. So in this case, this matrix, the first non-zero entry are all equal to 1. Now, the first non-zero entry of consecutive rows also appear to the right, and that is what we have here. And then the rows of zeros appear at the bottom, and that is what is here. So we are saying that a matrix is in a row echelon form if the first non-zero entry of the row is equal to 1, and the first non-zero entry of consecutive rows also appear to the right or shift to the right, and then the rows of the zeros appear at the bottom. Now let's look at a different case here. Now let's look at this particular matrix 1 3 5 4 0 0 1 6 0 0 0 0. Of course, this is in a row echelon form because why? The first non-zero entries appear of the first row equals 1, and the first non-zero entry of the consecutive row also appear to the right, and then the rows of the zeros all appear at the bottom. Of course, that is what is happening here. Okay, now let's look at a different case and determine whether the matrix is in a row echelon form or not. So this particular question, let's look at it. 1 negative 3 2 7 0 0 1 4 0 1 7 negative 6. Now we are saying that this matrix is not in a row echelon form. Why? Of course, we have the first entry of the first row is to be 1, but the second entry here, we know that 1 should have been here. Of course, this place, but now 1 is here. And this one too, we know that this particular one here, it was supposed to be here, so that here will be 0. Of course, this is not in a row echelon form, but the issue is that you could see, as I said earlier on, the 1 here should have been here, and this 0 could have been shifted somewhere else, and then this one should have been where the 7 is. Okay, but there's a way out. Now, a case like what we have here, if we are to shift the row 2, so this is the row 2 and the row 3, if we are to interchange their position, the matrix could have become 1 negative 9 2 7. Then we are interchanging row 2 and row 3, so we could have had 0 1 7 6 0 0 1 4. So you could see that if we are to change the position of row 2 and row 3, we could have had the matrix in a row echelon form. That is also another way. If possible, you can change some rows, and if the matrix is not in a row echelon form, there is a way out if it is possible. So now, getting the understanding of a row echelon form of a matrix, we are going to write first of all the system of equations in a matrix form. So in this case, we are going to have negative 3. We are taking the coefficients of the variables. So negative 2, 4, 9 equals to 9. Then you have We don't have any y, so 0. We don't have any x, sorry, so 0. Y is 3, z is -2, and then it's equal to 5. Then the last entry for the last row is 4, -3, 2 is equal to 7. Great. Now the next thing to do here is to write the what we have done here is we have created an augmented matrix for the system. That is great. So the next thing to do here is to use the row operations to reduce the matrix to a row echelon form. I said earlier on that if a matrix is not in a row echelon form, there is a way out to write it in a row echelon form by using what we call elementary row operations. And when you do that, you are using the method to reduce the matrix to a row echelon form. That is great. So now if you observe carefully, this is what we have here. And we know that the first entry of the first row, let me call this row 1, row 2, and this is row 3. Now you can see clearly that the first entry of the first row is not 1. So what can we do here so that the first entry of the first row becomes 1? Now we know that when we take -1 out of 3 of row 1, so it means when we take -1 out of 3 times row 1 element, this one alone will become +1. That is what this is what I mean. -1 on 3 times -3. This one will cancel this, and 3 goes here 1, and 1 times 1 is 1. So here we have the entry of the first row to be 1. And then when you do that, the operation that you do will affect all the entries of the first row or all the elements of the first row. So when we take -1 out of 3 of row 1, the result should be written in row 1. So we are going to have, so -1 on 3 times -3 gives us, so now the matrix, the augmented matrix becomes, here will become +1. Then -1 out of 3 times -2 gives you +2 on 3, as well as this one to give us -4 on 3. -1 on 3 times 9 gives us -3. So we are done for the first operation at row 1. So we maintain all the elements of the row 2 and row 3. So we have 0, 3, -2, -2, 5, 4, -3, 2, 7. Great. Now we are still in the process. The next thing is that we want now we go to row 2. Row 2. We could see clearly that the first entry of the second row is 0. That is, we are good to go. But when we check the second element, that is A22, that is the 3, it needs to become 1 so that it follows the approach of a row echelon form. And so we need to turn this particular area into 1. And how do we do it? We know that if we take -4 of row 1, that is -4 of row 1 plus row 3. Agreed? Okay, so let's first of all find the the first element here in row 3. That is this place. Now let's ignore the 3 here for now. You can also as well as do the same thing. But first of all, we can also let this one become 1 at the same time. Okay. Now let's say we take 1 on 3 of row 2, and we write the results at row 2. Then we are going to have this first part to be 1. So 1 on 3 times all the elements or entries of row 2. So 1 on 3 times 0 gives us 0. So we are going to have 1, 2 on 3, negative 4 on 3, negative 3. 1 on 3 times 0 is 0. 1 on 3 times 3 gives us 1. And here we are going to have negative 2 on 3. And then here too we are going to have 5 on 3. Great. So we maintain the elements or entries of row 3. And that is what we have here. Sorry. Okay, so now let's look at the second one here. We are moving on to the row 3 element. The first, okay, so our next target will not be in row 2. That is where the thing is. Because actually you can see that there's 0 here at the first entry of row 2. So though we have 3, but if we are to go by this approach, we are going to get stuck and the work will become so very difficult for us. So now let's skip for row 2 and come to row 3, where our motive here is to make this place 0. Okay, before we come to row 2, now we know that if we take negative 4 of row 1, negative 4 times row 1, and we add row 3 elements to it, and we put the result as row 3 because this is where our target element is. Now negative 4 times row 1, so let's take for example, this is the first element. Negative 4 times 1 is negative 4, plus 4 is what? 0. Great. So negative 4 times 1 is what? Negative 4, plus the 4 here gives us 0. So it means that the elements now becomes 1, 2, 3, negative 4 on 3, negative 3, 0, 3, negative 2, 5. So we are doing operation and we will send all the results to row 3. So as I said earlier on, negative 4 of all the row 1 elements. So negative 4 times 1 plus 3 plus the element at row 3, they are corresponding. So this and then this one to this, and then this one to that, and this one to this. So negative 4 times 1 is negative 4 plus 4 gives us 0. Negative 4 times 2 on 3 plus 3. So negative 4 times 2 on 3 plus the 3 here, corresponding elements over here, gives us negative 22. It gives us negative, it gives us 17 on 3. So here we have 17 on 3. Then the next one is negative 4 times negative 4 plus 2. Sorry, negative 4 on 3 plus 2 gives us 22. So here it gives us 22 on 3. So we have 22 on 3 here, as well as negative 4 times 3 plus root 3, which is 7, gives us 19. Because negative 4 times 3 is negative 4 times 3, negative 3, sorry, gives us 12, and 12 plus 7 gives us 19. So we have 19 here. That is great. Now let's move our concern or our target to the second element of row 2, where our motive is to make that place 1. Okay, so now let's go. What can we do? We know that when we take 1 on 3, so one third of row 2 elements, so that 1 on 3 times 3 gives us this place 1. The result should be sent to row 2. So now let's do the operations. So 1 on 3 of all the elements of row 2. So let's first of all write the elements of row 1 first. 1, 2 on 3, negative 4 on 3, negative 3. So 1 on 3 of all the elements at row 2. So 0 still maintains. Then 1 on 3 times 3 gives us 1. and then this place gives us 1 on 3 times negative 2 gives us negative 2 on 3. Then we have negative 2 on 3. Then here 2 will give us 5 on 3. 0, 17 on 3, 22 on 3, and then 19. That is great. Okay. So the next thing to do here, now that we have this place, so this one gave us 1 on 3 of row 2 or sent to row 2. The next thing to do is we want this particular place to become 0. This is 17 on 3, right? So when we take negative 17 on 3 times 17 on 3, then we add the results of root 3. Okay, so 17 on 3 plus negative 17 on 3 of root 2 elements. So where are the root 2 elements? These are the root 2 elements. So these are the root 2 elements. And so if we are to find negative 17 on 3 times all the root 2 elements, and we add root 3 elements, then we are going to have this place to become 0. Now let's check it out. Negative 17 on 3 of root 2 elements. So this is the place where we want to, let's pick this one, where the one is of 1 plus root 3, which is 17 on 3. Okay, so we have 17, negative 17 on 3 of root 3 plus 17 on 3. So here we are going to have negative 17 on 3 plus 17 on 3. Okay, so you have negative 17 on 3 plus 17 on 3, and that gives us 0. So negative 17 on 3 plus 17 on 3 gives us 0. Okay, so if we perform that operation, then it's possible to turn this place to be equal to 0. So you have 1, 2 on 3, negative 4 on 3, negative 3, 0, 1, negative 2 on 3, 5 on 3, 0, 0. Now negative 17 on 3 of root 2 elements. So negative 17 on 3, negative 17 on 3 times negative 2 on 3. That is the corresponding element here, and this one to this. So negative 2 on 3 of that is the root 2 element there, plus this is 22 on 3. So checking this on the calculator gives us, this one gives us 100 on 9. And then the last one is negative 17 on 3 times 5 on 3 plus 19. This one too gives us 86 on 9. Let's enclose them. So this is what we just performed here. Of all the root 2 elements plus root 3 elements, results sent to root 3. Okay, now the next thing is to make sure that this place also becomes 1, so that we have the matrix in a row echelon form. Now when we take an inverse of this one, so 100 on 9 times 9 on 100, you see that this one cancels and this one goes here and you have 1. Great. So in this case, 1, let's repeat the elements, the 1, 2 on 3, negative 4 on 3, then negative 3, 0, 1, negative 2 on 3, then we have 5 on 3. Now let's perform the operations. So 9 on 100 of all the root 3 elements, and the result sent to root 3, because that's where our target element is. So 9 on 100 times 0 gives us 0. 9 on 100 times 0 here gives us 0. 9 on 100 times 100 on 9 gives us 1. 9 on 100 times 86 on 9 gives us 86 on 100. Great. So we have our matrix or augmented matrix in a row echelon form. So the linear system with the above matrix has it augmented solved using backward substitution approach. Okay, so this is what we have here. We have our x to be 1. So we have x, for the coefficient is already 1. And then this is our y. So 2 on 3 y. And this is our z. Negative 4 on 3 z and negative 3. And here too we have 0. We have y. And then we have negative 2 on 3 z. And then here too we have 5 on 3. Okay, and this one too we have 0 0. We have only z here that is displaced, and it is equal to 86 on 100. Great. Now we know that z is equal to 86 on 100. So z equals 86 on 100, and this is the same as 43 on 50, because 2 goes here, 43, it goes here 50. Alright, so the value of z is equal to 43 on 50. Now let's put value of z here, the second row. So you have y plus negative 2 on 3, but z is 43 on 50 is equal to 5 on 3. So here we are going to have y plus, this one goes here 25, and this one goes, okay, so you have 43 negative 43 on 3 times 25 is 75 equals 5 on 3. That is great. So now let's subtract. We want to find the value of z. So 5 on 3 minus, or so this one comes here, becomes plus. So 5 on 3 plus 43 on 75. And this one gives us 333. Sorry, 336 on 150. That is great. So we substitute the value of y and z2 here in the first row. So you have x plus 2 on 3, y is now 336 on 150, and then z equals, z is what? Negative 4 on 3, z is 43 on 50. Okay, should be equal to negative 3. Now when we perform the operation, we are going to have x to be equal to 846 on 150. So this is a way to use the Gaussian elimination to solve systems of equation by using the backward substitution and applying the row echelon form approach to solve a system of equations, sorry, of this nature. Thank you very much, and don't forget to subscribe.